Today I'm at the University of Exeter, visiting marine biologists Dr. Ceri Lewis and Dr. Adam Porter, who are part of the blue carbon invertebrate team on the Convex Seascape Survey. They are studying something called bioturbation, and I'm here to find out what that's all about.
Our main role in the Convex project is to really develop an understanding of the processes that marine animals do at that interface between the mud and the seawater in terms of moving blue carbon up and down in the water column.
So when we go down to the muddy shores, we'll take a garden fork and we'll stick it in the mud and we'll turn it over, and we'll be able to access the organisms that are living beneath that surface. So we might find harbour ragworms, we might find clams that have buried themselves in the mud.
We know a little bit about bioturbation. That's mixing, basically, that happens when organisms make their burrows in the mud. But we only know it for a few species, and there are hundreds of species that live in our benthic muds that are really important for biodiversity, but might also be doing important jobs in moving blue carbon around, and how much they are helping bury that carbon as it settles out from the water column into those deeper muds where it then becomes sequestered and locked away.
So I think one of the most magical things about marine biology is uncovering what is below that impenetrable blue sea, or in the case of mud, the impenetrable brown mud. So when you walk down an estuary and you look out at those mud flats, it might look like there's not much going on, but in fact there's an incredibly diverse ecosystem working away and maintaining its stability.
So one of the things we're going to be doing in this project, which we're very excited about, is running the Great British Bioturbation-a-thon. We're going to get bioturbation rates for as many different species as we can. We're going to be doing this work up in Millport in Scotland, and we're basically going to be coming up with the top trumps of bioturbation rates for as many different invertebrates that live in mud as we can find.
Hi Ceri, hi Adam.
Hi.
Nice to finally meet you guys. So I hear you've been collecting these worms on the estuary today. So can you tell me a little bit more about them and why they're important to study for the Convex Seascape Survey?
Yes, absolutely. So let me introduce you to this handsome fella here. This is our common harbour ragworm called Hydistes diversicula, that's its Latin name. And these are really important invertebrates living in the mud in our estuaries. They're really good at burrowing into the mud, and you can see they've got these wonderful little paddly legs. They're called parapodia, which makes them really efficient at burying into really fine silty muds. And they make lots and lots of mucus, so as they're burying, they're creating these burrows, they're also solidifying that mud, and they change the structure of mud. The burrows that they make enable the nutrients to be exchanged with the water, and that's why they're so important for recycling nutrients in estuaries. It's this process called bioturbation, mixing, aerating the mud and allowing the microbes in that mud to then do their job of recycling those nutrients. And there can be hundreds, if not thousands, of these worms per metre squared in an estuary, all doing this job, doing what we call an ecosystem service, this nutrient recycling. And what they do is they feed on the surface of that mud by making this mucus burrow around them, and as they draw themselves back into the mud, they draw the mucus with them, and all their food gets stuck to that mucus and they're drawing it into their burrow. So again, moving things around and helping this recycling process.
So with this mucus layer they form, is this how they draw carbon down into the sediment?
Absolutely, that's how they're drawing organic matter from the surface of the sediment where it's settled out from the water column downwards into that muddy layer. What we don't know is how far down that travels and how much of it stays down and how much of it's just actually being mixed around in that sediment, and that's part of what we'll be looking at with our experiments. So I'll let Adam show you what happens when we have some mud in the beakers and we add the worms to the mud so you can see them burying themselves. Well, I'll just go and check on the tanks.
Oh, thanks Ceri.
Okay?
So what we've got here is 4 beakers and a bottle of estuarine mud, and we're going to pour it into these beakers, and then we're going to see what the worms do once they're put in their natural habitat. There he is. And then we can just add him to the beaker, and he can go in there, he'll bury it into the mud, and that is the start of his bioturbation, or mixing the sediment. So this is a replica of what we'll be doing in the big experiment up in Scotland.
Is that the big bioturbation-a-thon?
It's exactly that, yes. they create what we call a gallery, which is an incredibly intricate network of tunnels under the surface that can go from the surface all the way down to about 15-20 centimetres deep. And so all these different organisms are creating different burrows which have different impacts on how stable the mud is, and therefore how stable blue carbon is within those muddy sediments.
The bioturbation experiments that we're doing in Scotland will then help us narrow down our key champions of bioturbation, which we will then bring back to our fantastic research aquarium that we have here at Exeter University, where we'll be doing some really detailed experiments, really looking at following the carbon. We can label the carbon in a way that we can track it through experiments, but we can't do that on a big scale. That needs to be done very carefully in our research aquarium.
What we hope to learn from these bioturbation experiments is which animals are really drawing down blue carbon and burying it in the sediment. We have in the UK a brilliant resource of maps of which species live where in our muddy shelf seas. And so if we know which organisms are doing what, we can start to extrapolate. We can start to say, well, maybe lots of blue carbon is being buried by organisms over there, but not over here. And the implications for that are that if we're really worried about carbon, we're really worried about climate change, perhaps we should be protecting bits of the seabed so we don't stop those organisms from taking carbon from the water and burying it in the sediment.
I'm so excited to see what Adam and Ceri end up doing in Scotland later this year on their self-named bioturbation-a-thon. Please stay tuned and follow our social media channels, and thank you for watching.